Okay, today is Unit 6, Day 8, and we are going to talk about solving radical equations. So we're going to give you some equations where typically there's an x under the radical and we got to solve for it. So take a look at some easier radical equations by undoing the operations. So I want to do undo a square root. So if you square root something, I can undo that by squaring it. So in this case, if you have the square root of x equals 2, I could just square both sides, and anytime you square root a square, basically it wipes it out and you just have x left over. 2 squared is 4. Okay, so in this case, if I plug in 4, what's the square root of 4? It's 2. So that's my answer. Same thing here. Square root of something is 9. Well, let's just square root, or let's square both sides. So if I square root it and then square it, I'm back to where I started, x. 9 squared is 81. There's my answer. If it's a cube root, then I have to cube it to get rid of that. So I'm going to cube both sides. So I take a number, I cube root it, and then cube it. I'm back where I started. 3 to the third power would be 27. So if I take the cube root of 27, I do get 3. Okay? So that's the main operation right there. If you need to get rid of a radical sign, whether it's a square root or a cube root, you're going to use an exponent to do that. But sometimes you have to do a step first. So like here, when solving, it's important to isolate the radical first. Up here, the radicals were all by themselves. They're on a side of an equation by themselves, so I could get rid of them using the exponent. These guys aren't by themselves yet, so I need to get them by themselves, then get rid of it. So isolate the radical first. So in this case, here's my radical. I need to add 3 to both sides first. So I have radical x equals 5. Now square both sides. So x equals 25. Okay, next one. Here's the radical. It's not by itself because it's being multiplied by 3. So let's get rid of it first. Divide by 3. So now radical x with the square root of x equals 4. Now square. So x equals 16. Over here, right here is my cube root. I need to get rid of the negative 5 and the negative 3. Do the same order you would solve other equations. Like in Algebra 1, how you solve equations. You'd want to add or subtract first and then worry about the multiplication and division. So I want to add 5. And then divide by negative 3. I want to get rid of that negative 3. So I got the cube root of 9x equals negative 3. Now, I got my cube root by itself. Yes, there is a 9 there, but the 9 is inside the radical. I can't get rid of it. You can't do that. You can't break it out, so you have to get rid of the radical next. So I got 9x is going to equal negative 27. Now divide by 9. So x equal negative 3. And on any of these, you can check yourself by plugging it back in. I could plug this back in up here. Negative 3 times 9 is negative 27. The cube root of that is negative 3. Negative 3 times negative 3 is 9. 9 minus 5 is 4. So it works out. Let's up the difficulty level a little bit here. So we're going to do a little bit more crazy ones. But the main idea is we want to make sure that we have radicals by themselves. On this first equation, the radicals are by themselves. And that's good. It's a really easy first step. Now, to get rid of them, I'm going to square. So I might say I want to get rid of this radical. Well, in that process, you actually get rid of both radicals. So when I square both sides, both radicals disappear. And it's just a normal equation like you would have done in Algebra 1 now. So I'll bring the ends to the left side. Add the 2 over. And now divide by 2, so I get 4. Okay. Number 8. Now I've got a radical on one side, and it's already by itself. That's a good first step. It said isolate the radical first, and it is isolated. So let's square. Now on the right side, that's easy. X plus 13. The left side, I'm taking x plus 1, and I'm squaring it, so it's really x plus 1 times x plus 1. So I have to FOIL that guy. Okay, so if it helps you to write it out, write it out. If some of you remember the shortcut is the first term squared. and then it's a first times the second, and then double it. So x times 1 is x, and double it would be 2x. And that's because when you take outer plus inner, it's 1x and 1x. You're doing the same thing twice, you could just double it. And then the last one squared would be plus 1. Okay, so now I've got a quadratic on one side. Well, the only way to solve a quadratic is to get it equal to 0. So I'm going to subtract x from both sides, and I'm going to subtract 13 to save some room here. I'm going to do both in one step. So on the right side I got 0. I got x squared plus x minus 12. Let's factor that. Okay, so I know it's been a while. It's been about a month since we had to factor anything, but this one's easy because it has a 1 in front. So this is not the harder kind. So it's just x and x. What two numbers multiply give you negative 12, add to give you 1. So if it's a negative product, it's plus minus. And in this case, I could do 4 and 3. 4 times negative 3 is negative 12. 4 plus negative 3 is 1, so this is our guy. So that means x equals negative 4 or 3. Now here's the thing. Sometimes on these problems, you have a solution that's not a solution. Okay, this came out. These are came out when I worked it. The problem was at one point, whenever I squared, I may have added some solutions because some numbers can't be square rooted here. Okay, so what I'm going to do is I need to plug these in and make sure they work. So I need to plug in negative 4. I need to plug in 3. Let's plug in 3 first. So plug in 3. So we have 3 plus 1, and I'm going the original equation, by the way, the original equation, and the square root of 3 plus 13. So on this guy, 3 plus 1 is 4. 3 plus 13 is 16. Square root of 16 is 4, so that one's good. Okay, so when I plugged in 3, it worked. Now when I plug in negative 4, let's plug in negative 4 here. So negative 4 plus 1, does that equal the square root of negative 4 plus 13? Well, negative 4 plus 1 is negative 3. Right off the bat, I can't square root and ever get a negative. So I kind of know something's up here. But this would be negative 4 plus 13 is 9. Square root of 9 is 3. These do not equal each other. So negative 4 is an extraneous circumstance. So the extraneous solutions is negative 4. So I would throw that out, and 3 is my answer. Okay, this was extraneous. It came in as an answer because anytime you square a binomial, you may be adding solutions that really don't work. It's kind of hard to explain why. The easiest way to find it is plug it back in and make sure they both work. So backside now, it's going to be a whole bunch of examples. If you feel pretty confident with this, go ahead and pause the video and try it out. Go ahead and work ahead and see if you can do these on your own, and then just fast forward the video and look at the answers. Otherwise, if you still feel kind of uneasy or not so confident, you can watch. The big idea is get the radical by itself. Okay, so isolate the radical first. Isolate the radical first. Right here's the radical. So I'm going to get that by itself first. I'm going to subtract 3. Divide by 3. Okay, now I can get rid of the radical by using an exponent. So I'm going to cube both sides. So x equals 64. If you plug that back in up there, it does work. So you're checking for extraneous circumstances. You can check if you want. I can tell you it does work. This guy here, here's the radical. Get that by itself first. I'm going to add 7 to both sides first. So this would be the square root of 2x plus 3 equals 7. Now square. And then solve like a normal equation from Algebra 1. Okay, if you plug that back in, 23 times 2 is 46, plus 3 is 49, square root of 49 is 7, 7 minus 7 is 0, so it works. This guy here, I do not have the radical by itself, so right here is the radical. That needs to be by itself on one of the sides of the equations before I can square anything, so I'm going to add the 2x over. Now I'm going to square. Now 2x squared, that's 2x times 2x, so it's actually 4x squared. So be careful on that. A lot of students will put 2x squared, but it's 2 squared and 4 squared, so 4x squared. Now it looks like I got a quadratic setting up here. I got x squareds and x's. Get everything to one side. So 4x squared minus 11x minus 3 equals 0. Okay, this one's a little bit more difficult, and if you don't like factoring, you could use quadratic formula here if you'd like, just kind of speed things up a little bit. But this guy, I'm going to try 4x and x, and I'm looking ahead. I did cheat a little bit here. I've already done these problems. So this is a plus 1 and a minus 3. So what I did there was I picked numbers that multiply, give me negative 3. You could do different orders. You just keep rearranging things. But the key is the outer product plus the inner product. So 4 times negative 3, negative 12. The inner product's 1. Negative 12 plus 1 is negative 11. So that's how I knew this was the right combination of everything. This means x, well, the easy one is this is 3. If you remember, the shortcut with this guy was I'm actually setting 4x plus 1 equal to 0. So I would subtract 1 over, so it would be a negative 1. And I would divide by 4 to get x by itself, so it's negative 1/4. Go through, plug these numbers back in. If you plug in a negative 1/4 in here, so negative 1/4 times 11 would be negative 11/4. If you add 3 to that, and in square root, that does not work out to subtract 2 times, or to add a half to get 0. So this one actually does not work. And like I said, I'm trying to save time. If you plug that in, it doesn't work. Plug in your calculator and set it does not equal 0. But this one does. So only 3 is the right solution here. So a lot of times when you are looking at a quadratic, one of those may not work. They might both work. They might neither one of them work. Sometimes you don't get an answer. Sometimes there's no solution. This guy here, the radical is by itself. So go ahead and square both sides. Again, I'm squaring this, x squared, then x times 1 and double it, so it'd be 2x, and then 1 times 1 is 1. If that didn't work, if you don't get that shortcut, just write it twice. X plus 1 times x plus 1 and FOIL it. Now, if I bring everything over to one side, stuff goes away. It's kind of cool. The x squareds are going to go away, and we like that. So this would be 2x minus 2. So it's not a quadratic. I don't have to factor. Now I just got to solve for x. So bring the 2 over. That'd be 2 equals 2x divided by 2. X equals 1. Check it out. Plug it in. 1 plus 1 is 2. So this side would be 2. Plug 1 in here. 1 squared is 1 plus 3 is 4. Square root of 4 is 2. So 2 equals 2. That one works. Then the last situation here. Here's the radical. It's not by itself, so get the 5 out of there first. So I'm going to add 5 to both sides. So square root of 3x plus 13 would equal x plus 5. I got the radical by itself, now square. So this would be 3x plus 13. Okay. If you like the shortcut, try it out here. So this would be first term squared. First times second is 5x, double it. So it would be 10x. And then last term squared is 25. Again, if you didn't get that, just write it twice and FOIL it out. Now, get everything to one side. So minus 3x minus 13. It's got 7x plus 12. That'd give me, let's see, so plus 3 plus 4. So x equals negative 3 or x equals negative 4. Now go ahead and check both of those. Plug those back in, and they do both work. Okay, so I'm trying to save time in the video, but if you plug those back into the equation, it balances out. So there's a situation where both of them work. Again, having neither one of them work is also a possibility. So look, be aware of that when that pops up.